in, turn them in immediately, and I'll try and scoop them out there as quick as I can and get you feedback on if you're doing things right or wrong. So we're going to start grabbing people and look at your coursework. We'll do a degree audit, make sure you're on track, and we're both on the same page. Okay, so we'll start that today. It's going to take probably 2-3 days, so into next week before we have a chance to get all of you. I do have a list of all of you that have outside courses. You are going to get priority, so that, because those are the ones that fill up. Nobody can take your drafting courses. So that's all you have left. You're in good shape. All right, so let's jump into some dimensioning stuff. First thing, set figure 17.3. This is a technique called dual dimensioning. Now don't confuse this with double dimensioning. When I grade stuff, you know, when I use LW, does everybody know what that means when I'm grading something and I say LW?
Line weight.
Okay. LQ, line quality. You might see another one, and I hope you don't see many of these that are DD on your drawings. That means double dimensioning. Don't confuse that with dual dimensioning. Okay, dual dimensioning is something we do. Double dimensioning is something we don't do, and we'll explain that more later. So dual dimensioning is shown right here. There's two ways to do it. This is really the preferred way. In essence, with dual dimensioning, you are providing 2 units of measure on the same drawing. Typically, this would be English and metric. And the nice thing about this, if we do it by hand, how do we get these numbers? We use a calculator. If you're doing it on the computer, it will do it for you automatically if you wish to do this type of dimension. Certainly, if you think your drawings are going to a place where they use metric dimensioning, namely overseas anywhere, it's a good idea to do this, okay? Or go straight metric to the people that do it. Okay? So you want to kind of think of the breeders downstream, right? Our job is to really make their life easier while still giving them the information. So this is a good technique for it. And yes, if you work in Twin Falls or Burley or somewhere like that, that doesn't mean your drawings are staying in Burley and Twin Falls. Just so you know, we actually have a very transient workforce when it comes to that. What's our main manufacturing in the area? Does anybody know? If we're talking manufacturing or mechanical, what industry really supports that?
Nuts and
Washers.
washers, yeah.
Okay, well, I kind of mean more like an industry. An industry. You work for one.
Oh, amalgamated sugar?
Yeah, what are they? Food processing
Yeah.
facility, right?
Oh, yeah.
We're ag-based. And really, if you get into the mechanical world, that drives everything we do here. We've got a couple places that do things outside of the ag world. But for the most part, you got Falls Brand, you got Sugar Factory, you got McCain's, you got Chobani, you got Cliff Bar, you got the old ConAgra. I can't ever remember who bought them out. What's that?
Lamb Weston.
Yes, thank you. Lamb Weston.
Jerome cheese.
Yeah, we got tons of those, right? What do they use in every one of those facilities so that they don't get bacteria on their stuff?
Stainless steel.
Think of a steel that does not let
Stainless steel.
bacteria
Yeah.
grow.
Stainless.
Stainless. Top producer in the world of stainless is Austria. Most of our stuff is built there and shipped back here. But keep in mind, you can be working here and your drawings are not being used here. They're getting sent somewhere else, things are being built and then shipped in. And that not only happens across the states, it happens across the world in today's climate. So keep that in mind. You may have to use this. When we get into the computer and do this, we'll certainly take time to show you how to do this because it is a part of it. So if you see that, namely one dimension, the one the main drawing is supposed to be on, brackets next to it, and notice the type of brackets, it's a square bracket. Those are the metric dimensions. If you get a company that wants to do them this way, you can do them here, where you put the main one, whatever you're doing on top. So for us, it would probably be the English units on top, and then the secondary one underneath, where you'd put that line. Now remember, you have to have that line, because we had another dimensioning style called limit dimensioning that had 2 numbers stacked on top of each other that was a tolerancing technique. So if you do it, you have to have that line. Let me just make sure you're aware. You want to make sure that line's on there. I like the brackets myself because it gets away from that. But what you don't want them to get confused with is over here on the next page. I'm going to look here. Here's a case of limit dimensioning, which is a tolerancing technique. We talked about that yesterday. Again, you have numbers stacked here, but no line in between them. Okay, so that's the difference between the two. Now, you don't have to tell somebody you're dual dimensioning. You either use the line or you use those brackets, and they should know that. So, dual dimensioning, providing 2 units of measure on the same drawing. Yes, sir.
Are there ever any instances where people are flipping back and forth between the English and the metric? I mean, I remember you mentioning that one of the NASA catastrophes was caused by that.
Yeah.
I mean, so is
That was
it-
30 years ago, what, $4 billion, which was big dollars. Not so much in today's world, but, well, still big dollars, but, yeah.
But is that something that's typically gonna be read all metric, all English, or are there situations where they just go back and forth?
The problem happens when we do go back and forth. Like we take an English drawing and we're building it with metric tools and we've got a technician sitting there crunching every single number. That's where you're just begging for errors. You're just begging for it. Okay.
Does having it dual mitigate
Yes, it
some
does.
of that?
Mhm. Yeah, because you've given them, both of them, they don't have to pull that calculator out and figure that number. And if you draw a true size in the computer, we're not gonna do this by hand. But you draw this in the computer 1-to-1, that's why we keep that geometry 1-to-1. They keep telling you folks, you get a desire to scale that geometry, slap yourself and say, don't do it. This is another reason why. Because the computer is really a Cartesian grid and we can get it exact and it won't make mistakes.
So would you have to include anything in like your little notes or anything like that
No.
for this? No?
No.
Okay.
You do include the same tolerancing techniques and everything for your main unit of measure. So your main's outside.
Uh-huh.
So if I'm doing English units, then I would still give them a tolerance in English. I'm not going to give it the metric tolerance. They would have to convert that tolerance.
Okay.
Do they ever have situations where it's all in English, but then they say, then you have both options for the screws, metric or English?
No, almost never. And the reason is that the threads are different. They are not equivalent. You can't go buy a 1-inch UNC, Unified National, which is our thread, and then compare that to a 25 mm thread because they're different threads. They won't screw onto the same nut.
Yeah, I've tried it and stripped it before.
I think we've all done that. Yeah, it's pretty frustrating working on a car in today's world where you got to have both sets of wrenches. And yeah, that's pretty aggravating. So no, typically stick with your center. Now, it will be just English units to here. We'll put a drawing out later that has difference. Okay, double or dual dimensioning. Okay, let's talk a little bit of text. Let's go to page 822. We're looking at figure 17.6. Now what this diagram for, it's actually a little bit wrong, but it's for how you control your dimension line as dimensions get smaller and smaller and smaller. Okay. And some guidelines. Now first off, let me just state that what we really want is this guy right here, okay, where we have an extension line, a dimension line that terminates, and our text in the center. That's what we want. Now, as things get smaller, though, you aren't going to be able to do that. So when we come smaller, the first thing we always do is pull out the arrows and the dimension line. We pull those out, leave the text centered in. Now, keep in mind that we're 2 decimal places for the most part. If metric, we're 0 decimal places. So you have got to have at a minimum in here 3 places, right? 1.00 or 0.085, whatever the case, 0.8. So you're going to have 3. So that's going to require about 1/4 to 3/8 to get this in here. Then you pull this out. Now when you're drawing these guys, remember the arrowhead is an 8, right? How big a stretch do you put there? Use the same as your arrow. Okay, put 1/8 of a line on it. Okay, and that should be your minimum. Can you go a little bigger than that? Sure, if you have room. But have at least 1/8 on that line right there. So somebody sees it. They shouldn't see just an arrowhead with just a little knob on there. It should be an 1/8 line so that they don't confuse it with something else. Step C doesn't happen. Dimensionally, that will never happen. So I don't even know why the author has it in there. Now, once it gets small enough you can't put the text in, then you pull everything out. Okay. Now we take the text, we generally just line it up right on the outside and put it. You can't always do this because sometimes you'll have a bunch of these. Let me just kind of draw it where I've got 0.25. Now I've got another 0.25 right here. Well, I can't put this arrow right here, right? So we kind of drop back 10 and punt in these situations. By that, we try and make it as clear as we can. I can come in and do this, where I just do the 2 on the outside. If I don't even have enough room for the text, what I would then do is do that, and then I would pull a leader. Okay? So if I don't have room, I might then come out and do 0.25, and I can use a dot or an arrow, and then I would do the same over here. That goes into that area. That's only if I can't put it over here, because this would be the preferred location. Yes?
Would you leave that space in between or would you draw a line?
You can do both.
Okay.
The computer will actually do both too, where you leave this line coming right through here.
Yeah.
And it's going to be up to whoever employs you and how they want that to work. For here, I would say don't put anything. Okay, don't put anything.
Don't put that line across it all.
No, just leave it blank.
Just leave it blank.
Okay? We want that gap. And that's really, there's no rule or anything that states that, other than Pat Farrell's rule. I think it reads better. Okay? After looking at these for 30 years, I just like the way it reads as opposed to the line. But your employer may change that. You need to do what your employer wants you to do. Yes?
Can you go back one step, when you had that thing, you fit it in there, you wouldn't put 0.25 on one side and 0.25 on the other side? Wouldn't put it,
Yeah.
would you put it outside and
Now,
outside?
I can do this way and this way.
Okay, you can do that?
Yep.
And if you could fit them inside, you put them both inside?
Yeah.
So any of those ways are acceptable?
Right.
Okay.
Really, the bottom line is we want this. As it gets smaller, we move to this. We pull the dimension arrows out. And then as it gets smaller, we pull everything out. Okay. So that goes with all of these. I think there's another figure on this that the author gives you also for metric. And in essence, the C on it is also wrong. Is it right below this or right? Right below it, isn't it? Yeah, they're doing metric right below. Again, C will never happen on this. Here, it will never happen. But you do the same process. Okay. The other thing on text. By the way, on page 825, they kind of compare and contrast again. That kind of same thing. Again, C won't happen on this one. I'm not sure why the author's got this duplicated, but he does. Okay, let's go to page 828 and look at a little more text. We have 2 text standards out there on how to place the text. And get this to where we can see it. These are called unidirectional or aligned, and it has to do with the way your text is read. Okay. Unidirectional is this guy. This is the ANSI standard. And in fact, everybody has gone to this. They switched to this in around 1994, and since then, everybody has adopted it except for one discipline. Any ideas which one that might be?
Architect?
It's going to be a reoccurring thing. They do their own thing. Everybody except for architects uses an aligned or unidirectional dimension style. All that means is your text always reads from the bottom of the page. Okay. So by that, notice as we come through the dimensions, they all read from the bottom. That will be all of your engineering disciplines use that. The metric system also uses unidirectional.
What do you mean when you say it reads from the bottom?
It means for me to read this dimension, I don't have to rotate the page to have it read for me.
Oh.
As opposed to, let's just kind of go one step further, maybe that'll be a thought. We do have another standard out there, it's this one's called the Align. Now here, your text will always read from the bottom or the right side of the page, and that's it. Bottom or right side. But here we take the text and align it with the dimension. Okay, so you can see it's been, here it's just like unidirectional because it's given a width that you could read from the bottom. Here they're given heights, notice they've rotated the text. Okay, this is an aligned style. Architecture uses this style, but nobody else really does. Well, structural does too, but they stick on architectural drawings. So unidirectional, the ANSI standard, aligned, the AIA standard. AIA stands for American Institute of Architects. They have their own standards, but it's that big red one over there on the bookshelf.
So that second lined old standard, where that it has that dimension of that one, it only has the little arrows. It doesn't have the little.
Yeah, we won't do that.
Okay.
We'll pull our arrows out
Okay.
on that. That's a good example though of what we were just talking about, right?
Yeah.
You can't see that line. Okay.
Okay.
Did you have a question, Cheryl?
This is about text, but not this specifically. When you're doing notes on here, on the page, notes, you write notes at 1/8,
No, 1/4.
one quarter, and then you have a space, and I made that space 1/8. Is that correct?
Yeah, that's fine. Use half of your letter height.
The
And
one
so-
above it.
Yeah, since you're coming from 1/4 to an 1/8 text, then you're kind of in that gray area right there. Just stick with 1/8. Give it a little separation. And then you should be a 1/16 between all the rest of it. All right, so for us, text, we're unidirectional. While we're on this page, let's look at figure 1723. This has quite a few good things on this figure. Mainly, the author's just saying, hey, keep your dimensions off the object, because we want the object to be clear. Remember, this is really the geometry that's important. We don't want to mess it up by putting a bunch of dimensions on it like they do here. Now, you can put dimensions inside of a figure, but that should be a very last resort. As a general rule, pull your dimensions outside. Now, that causes a problem, because many times you start pulling these extension lines clear across an object. And people get a little confused on that. That's fine. Hey, remember, it's a thin line, so it shouldn't ever be confused with an OBJ line. So they should be able to see it. The problem you're going to run into, especially as you learn this process, is knowing when to break an extension line. In essence, it's only broke for one thing, and that is for a dimension line. So the thing I see is, a lot of times I'll see a little center line mark like we've always done, and then somebody will leave a gap and pull from there. Okay. No, there's no
Center
gap.
line, yeah.
Okay. We're essence doing, we're taking that center mark and we're turning it into an extension line. It should be straight. Should not be broke here. Don't break it around those OBJs. Okay. It should just go straight. No breaks in it whatsoever. Remember, it's got a 16th gap off of the extension line where it starts. If you're locating centers, there's already a 16th right here, isn't there? Off your center mark. Okay. So then you're going to pull that, and you do not break it for anything except a dimension line. And we can show you where the author's talking about this, because I want to clear that drawing up just a little bit also. Where does he have some stuff? I never wrote down a page number. Let me find it. Oh, here it is. It's back on page 827. So figure 1720. Here the author's showing you how you take a center line mark and you just turn it into extension lines and pull it out and what it should look like. Now, the figure right before that, 1719 on the other side of the page, or right on the other side of the column, shows when you do break them. Okay, so they're pulling this extension line up, and the author's saying break it around the arrows, really break it around the dimension line. Okay, the arrows are part of the dimension line, but if I'm pulling this thing out and I've got, let's say, I've got something here where I've got a dimension line, and for some reason, I have no idea why this would be, and I'm pulling another extension line that's going to come up through here, I want to break that around that dimension line also. Okay, and then keep it coming. Hopefully we never get into that case, but that's the way you would do that.
How big is a break?
Standard 1/8 inch is fine. That would give you a 1/16 on both sides of that line.
Okay.
So make your break 1/8. That's the only time we break it. And it's just so we get good clarity. See, like this one, in my mind, that one right there should be broke.
Okay.
Okay, where it's hitting that dimension line,
Where?
right here. Okay, see how he doesn't break it because he doesn't hit the arrow?
Right.
Yes.
How about the center line?
How about the center line? Can you kind
Should
of
we
point-
break it? Does it
No.
cross the center line?
No. Nope. Now, the only caveat, and I'm not really going to get into this too much today, we'll get into it a later time, is at times, we can take this center line and we want to break it as a center. So I can take my extension line and make that a center line and use it for an extension. Now, there's really only 2 or 3 instances where I will do that. And that is mostly if I'm doing like a pier deck and I'm showing somebody, hey, I'm hitting the center of all these features. And so I switch that to a center line saying, you're getting these centers, because I might have a small little column at a large scale and I want to make sure they know I'm hitting the center of that thing versus an edge. Okay, and that's about the only time I'll do it. I really, for us, consider right now, don't ever put it in the center line.
Okay.
This is going to happen in the architectural and structural worlds when we
What
switch that.
happens to the line weights when you do that?
Well,
Yeah.
what's the line weight of the center line?
It's the same.
Oh, it's the same line.
It's the same.
Would you just explode it and then make that one?
Yeah, I'd make it my own. For now, don't really do it. When we get into discipline stuff, I'll show you where those happen. And it's, in essence, we're just trying to clear it up a little bit. Another good example, 1717 here, they're talking about staggering on your text to make it clearer. Because generally we want all our text in the center, right?
Yeah.
Well, if you get something like this, where we've got a whole bunch of dimensions going on, they're saying stagger them so that you can read the text, because it's going to drift into the other way, especially using unidirectional in this type of setup. So you do need to stagger that text. Now, don't go willy-nilly on this. Make it read good. Okay? So don't go up one, stay up, go down, just kind of jumping all over the place. Have a rhyme or reason to it so it's predictable. Okay, so as you well know, your eyes work the same as your body. You know, some of you have been out there working a little bit, and maybe some of you have built staircases. Okay, but all of you have walked on stairs. You folks probably have all been into an old house where you're walking down a set of stairs, and then all of a sudden you and your foot falls an extra inch or so. You know, by the time you take 2 steps on any set of stairs, your body's already in muscle control and you're not paying attention. Right? You're just going. And then all of a sudden you get one that's a little weird, and your body reacts and you fall down on your face and break an arm and all that stuff. But that happens, right? It happens with your eyes too. So that's why I really give a lot of attention to making a drawing read well and stuff, because that all happens behind the scenes and people don't even know what's going on. That presentation of a technical drawing is just as important as presenting a piece of artwork.
If you have room, is it better to have them all centered?
Yes,
Or
if you have room,
to
we
try
want
to-
to center. Yeah, there's a case where we can't, we don't have the room. You can do obliquing if you get into a different situation. The obliquing note here, they're pulling a height dimension. But they could not get that all pulled off over here, so they obliqued them, pulled them at an angle. You can do that, make sure the angle stays consistent through all drawings. If you do it on one view at that angle and you're gonna do it on another view of the same part, use the same angle. Okay, a lot like hatching was, right? You tried to stay consistent from view to view to view. Notice on those, all of those extension lines crossing, and they are not broke. You do not break an extension line when you cross another extension line. You only break it for dimension lines. Okay? By that I'm talking to all these intersections right through here. Notice that they are constant through there. They are not being broken. Now, there's a dimensioning practice shown back on figure 1760 that should alleviate many of these problems. Put your short dimensions first in your first row. As you come to other rows, give more or larger dimensions. Now, at this point, we probably ought to talk a little bit about dimensioning styles. I was actually going to introduce a couple others first, but I think since we're on this figure, I'm going to do it. What I want to compare and contrast is this dimensioning style right here on, I just took my glasses off, on page 824 called coordinate dimensioning. Now what you'll notice on this, notice that all the dimensions are pulled from a fixed edge. Now look at this dimension style, what we call chain dimensioning, where we don't pull it from one fixed edge. It's coming from here, but then I've got another dimension that takes off from here, and then I might have another one that goes, keeps going. But not all of them come from a fixed edge. Now, which way is better? In essence, neither one's better, but there are some ramifications for using them. On coordinate dimensioning, this one, where we're pulling from a fixed edge, keep in mind every dimension has a thing called a tolerance on it. So let's say we have on this drawing